Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter motion. Now let's go for continuing this. And today is the fourth period of the chapter motion. And yesterday we completely focused on the numerical problems on speed and velocity, in addition with that average speed and average velocity. And one more important type of problem is there. I have written it on the board. Now let us go for solving this and observe the board and listen to me carefully. Here the statement is like this. A car travels 30 km at a uniform speed of 40 km per hour. And next 30 km at a uniform speed of 20 km per hour. If it is so, we have to find out the average speed. See that here the car is covering equal distances with the different speeds. Hence we need to find out average speed. Let us go for writing the given information. Here data. A car travels 30 km at a uniform speed of 40 km per hour. Here how many cases are there? There are two cases. See, in the first case, the car will cover a distance of 30 km. I call it as D1. And it has moved with a speed of 40 km per hour. Let us call that speed as V1. Next, again it covers 30 km. I take this as D2. D2 is 30 km per hour. 30 km with a speed of 20 km per hour, and this speed you can take this as V2. Right? What you are going to find out? VAV, that is average speed. Let us go for calculation. And observe here, when you go through all the terms, they are all in standard unit. Hence, no need to go for any conversion. To find out the average speed, we have a formula, that is VAV equal to D1 plus D2 divided by T1 plus T2. Then here D are known. What about T1 and T2? They are unknown. So first we have to find out T1 and T2. I hope that you have understood. Here, we all know that V is equal to D by T, which implies that T is equal to D by V. As I said, we need to find out T1 and T2. Here I'll write. Here T1 is equal to D1 by V1. What is D1? It is 30. V1, this is 40. It will be 3 by 4 R. Let us find out T2. T2 is equal to D2 by V2. What is D2? It is again 30 km and V2 is 20 km. 0, 0 get cancelled. It is 3 by 2 R. Next, let us go for substituting them in the formula. What is that formula? It is VAV is equal to D1 plus D2 by T1 plus T2. See, as T1 and T2, these two are in fraction. So, it takes more number of steps for simplification, or you may find discomfort to solve this. Hence, I go for finding first T1 plus T2. Here, T1 plus T2 is equal to, what is T1? It is 3 by 4. T2, it is 3 by 2. Go for taking the LCM. LCM is 4. Multiply 4 with first term. 4 get cancelled. 3. Multiply 4 with second term. 2 1s are 2 2s are 3 2s are 6. It will be 9 by 4. Clear? 9 by 4 R. Let us go for substituting D1 plus D2 and T1 plus T2 in this formula. What is D1? It is 30. D2, that is also 30. T1 plus T2, just we have found out, it is 9 by 4 together 9 by 4. It is equal to, what is 30 plus 30? It is 60. Then take the reciprocal of the denominator. It will be 4 by 9. Now 3 3s are 3, 2s are 0s are. What is 24s are 80. 80 by 3. You can write it in fraction or even in decimal form. So you can write it as 3, 2s are 6, 2 will remain 20. 3, 6 are 18, 2 will remain 20, 6 are 6 are and so on. It is approximately, we can write 26.67 kilometer per hour. VEV. So this is the approximate value, in bracket you can write approximate. And we can write conclusion. Therefore, what is the conclusion? Average speed of the car is this much. Therefore, the average speed of car is 26.67 kilometer per hour. Okay? Yeah. I hope that you have understood. Please do practice this problem also. Now we are moving to the next concept. You have to pause the video and copy from there to here. Copy that. Dear students, so far we have solved many numerical problems with respect to speed and velocity. Now we are going to learn another important physical quantity. I am not going to tell you, just I am going to give you some of the information as a hint. Just observe this and try to think what it may be. Look here. Here we have some of the pictures which I have drawn. The very first one. Look here. Here a runner is there, an athlete is there, he is running, right? If he has to reach his goal, what he has to do? So these are the pictures with respect to speed. What he has to do? He has to increase his speed, right? Then he has to run as fast as possible. Then here one more picture is there. Again it is related to speed. And assume that you will go to your school by bicycle from your home. You have just left your home and you start pedaling. Then you just think about the speed with which you start moving and also the speed with which you reach the school. Will it be same? In the beginning you start moving, you start pedaling more and more. But as you will be nearby the school, then you start applying the brakes, then you will slow down the bicycle, right? Next, and observe, this is third picture. Here it is the quite common picture that takes place in forest. Here cheetah is there, here is a deer, and the cheetah is running to catch the deer. Should it move with the same speed or should it change? Yes, it has to move faster. How much fast? It has to move faster than the deer. Then only it can catch it. Right? Here also there is change in the speed. Next. Here there is a roller coaster type picture is there. And this is the path or track on which an object moves. Look here. Here is the object. It is at rest. Then what is the speed? It will be 0. Then now it is coming down. When it is moving down, whether speed changes or not? Of course it changes. Increases or decreases? You just think of it. And now the object is here. It starts moving from here to here in a straight line. It moves with a uniform speed. Next, now it is going up. The speed will decrease, right? And after coming over here, again it starts going in the slope path. Now, here also the speed is increasing. So, in this situation, you can come to know that the object is, sometimes it increases the speed, sometimes it decreases the speed, sometimes it moves with the same speed. And one more example, you can observe launching of rocket. You all know that a rocket is to be launched with a speed of 11.2 kilometer per second. So that is the escape velocity of the rocket. So as it ascends, whether it changes its speed or not, yes, changes, increases or decreases, it will go on increasing. If it decreases, what happens? It will fall down. Got it? Now here is a ball. A ball is thrown from the ground. It is thrown vertically upward. When it is going upward, whether it will go on increasing its speed or decreasing its speed, just think over it. Whether it increases, if you think that if it increases continuously, then it never comes back. So it will go on decreasing its speed. Finally, it comes to a rest at some height. Then after that, it starts falling down due to gravitational force of the earth. When it is falling down, whether its speed increases or not, yes, it increases, right? And here also, a ball hit by a batsman with a bat. Look here. Here I have shown the position of the ball. Here the ball, whether it is increasing its speed or decreasing its speed, it will go on decreasing its speed. Then it finally comes to 0. Then again it starts falling down. And one more situation. Here the football. A football player will kick the ball, and here this is the path of the ball, or the direction in which the ball has moved. See that in all these cases, the objects are changing their speed. Sometimes they move faster, sometimes they move slower, sometimes they move with uniform motion, right? As there is a change in the speed, it can be calculated with respect to time. Can you tell what you call the physical quantity which represents the change in velocity of a body in unit time? Yes, your guessing is right. It is acceleration, right? So today we are going to learn the concept called acceleration. It is one of the most familiar word to us, because many times we have used it. When your uncle or else your father is riding the bike, then sometimes you tell that you just go for increasing the speed. Will you use the same word? No, you will use the word acceleration in a different way. Give accelerator like this. Is it not? The actual word is acceleration. Then what is acceleration? Now let me write the definition of acceleration with its formula. But before that, once I tell the definition, you recall it. The rate of change of velocity of a body is called acceleration, or the change in velocity of a body in unit time is called acceleration. Okay, now I go for writing the definition of it. Dear students, here I have written the definition of acceleration. The change in velocity of a body in unit time is called acceleration, or the rate of change of velocity of a body is called acceleration. Just I go for taking an example. Assume that this point A is initial position of the object. Obviously, what is the speed of that object? It is 0. You may call it as 0 meter per second. Then after some time, he comes to the position B and start moving with a speed of 5 meter per second. Then again comes to the position C and it will be about 6 meter per second. Then here position D, and here the speed will be 3 meter per second. You can observe that here the body is changing its speed, or a person is changing his speed after some intervals of time. Got it? There is change in velocity. He has changed the velocity from 0 to 5 meter per second. And here 5 meter per second to 6 meter per second. Then 6 meter per second to 3 meter per second. The velocity is being changed in the unit time. And this is what we say the acceleration. Hence, the acceleration can be found out by using the formula. Let me go for writing that formula. Formula to find out acceleration. Here, acceleration is equal to, what is that? Rate of change of velocity. That is change in velocity. To change that velocity, how much time has been taken? That should be written. Change in velocity by time taken. But how do you find out the change in velocity? When you go for taking only the position of the person from B to C, look here, he has changed his velocity. How much? He has changed by 1 meter per second. How do you come to know that? You will subtract 5 from 6. When you take only these two positions, here but B is called, it is 5 meter per second. It is called initial velocity, and this is final velocity. Change in velocity is final velocity minus initial velocity. Here, when you take these 2 points, C is at C, the speed 6 meter per second will be initial, and this will be final. Clear? Hence, we can write change in velocity as final velocity minus initial velocity by, again, time taken. And symbolically, it can be written like this. Acceleration is denoted by the symbol A. Then final velocity is denoted by the symbol V. Do remember, V is final velocity. Initial velocity is denoted by the symbol U. V minus U by time is taken as T. So V is equal to V minus U by T is the formula used to find out acceleration. Clear? Okay. Then what about its SI unit? Yes, can you guess? You can find out SI unit by using the formula only. Here, change in velocity by time taken. What is change in velocity? Nothing but velocity. Unit of velocity is meter per second by time, that is second. It is equal to meter per second into, here second by 1. It is 1 by second. It is equal to meter per second square. Clear? Symbolically, it can be written as ms raised to the power minus 2. Got it? So this is the SI unit. SI unit is meter per second square, or symbolically, it can be written as m bar s square, or s raised to the power minus 2. See, here we have come across different physical quantities. You must be aware of their SI units. Distance and displacement is same, that is meter. Speed and velocity is same, that is meter per second. And acceleration is meter per second square. Now, acceleration will be considered when a body moves along the straight line, right? Then, whether it is scalar quantity or vector quantity. Yes, it is a vector quantity. You are all right. It is a vector quantity. Got it? Please do remember these points. Definition, formula, SI unit and physical quantity. As we know that sometimes the body has to move faster, sometimes it has to move slower. Example, what I said earlier. Here, the cheetah is running faster to catch deer, right? Here, whether the change in velocity should be more or less, it should be more, because it has to move quickly. In this case, here a boy is reaching the school, he is riding the bicycle. When he start approaching the school, whether he has to increase his speed or decrease its speed, he has to decrease the speed, right? So, if in general, if there is change in velocity, whatever the change in velocity will be there, if it is increasing, we use the word acceleration. If the change in speed is decreasing, then we call it as negative acceleration. This negative acceleration is also called retardation or deceleration. It is the opposite or antonym of the word acceleration. I am going to write one more word. It is deceleration. D-E-C-E-L-A-R-A-T-I-O-N. Deceleration. Also called, it is retardation. Let me write that. Retardation. And retardation is nothing but the negative acceleration. Now, let me give you the definition of negative acceleration. Nothing but deceleration. When a body moves along a straight line, if there is change in velocity or if it decreases its velocity with respect to time, then it is called deceleration. Now let me go for writing the definition. Just observe. I'll go for taking an example before writing the definition of this, because it may not be clear to you, so that I take the example. Here you are reaching your school by bicycle. Now you are riding the bicycle at this point with a speed of the 6 meters per second. You are approaching your school. Then within 1 or 2 seconds only, you are going to decrease your speed by 4 meters per second. Then immediately you will come to 1 meter per second. See here, what about the speed? What is happening? Whether the speed is increasing or decreasing? Here, decreasing, right? So there is the change in the speed. That change in the speed is decreasing, and we call this as negative acceleration. Now we can define deceleration as the decrease in the change in velocity of a body in unit time. Here I write the decrease in change in velocity of a body, change in velocity of a body in unit time is called deceleration. It is also called retardation, nothing but negative acceleration. Even you can write it as the negative acceleration is called retardation or deceleration. Retardation or deceleration. Then what about the formula? Formula will be same, that is A equal to V minus U by T. But only the thing is, here final velocity will be less and initial velocity will be more. So that is why you will get A as negative. Clear up? In that acceleration, V is greater than U, but here U will be greater than V. Understood? And the SI unit is same, meter per second square. It is also a vector quantity. Clear up? Now you have to pause the video and start writing from here and copy up to here. Dear students, now I am going to take another simple example to discuss more about acceleration. See that here we have a ball. What happens when the ball is thrown vertically upward? It reaches some height. Then after that it starts falling towards the ground. You know the reason for that. It is due to acceleration. It is due to the gravitational force of the earth, which will be studied in the another chapter. But you just observe, when the ball is falling towards the ground, whether the speed changes or not. Yes. How do you come to know that whether speed changes? As it is approaching you, you find it difficult to catch it, because the speed with which it is coming will be increasing continuously. Then how much? Just here I draw that. Look at the ball. This is the ball and here is the ground. And you are leaving the ball with some height, or the ball is falling towards the ground from some height. Then it is the maximum height at which the ball has reached. What is its velocity? The velocity will be 0. Now it is falling towards the ground. Then in first second, do you know what will be its velocity? Velocity will be 9.8 meter per second. Then after next second, after another second, then the velocity will be increased from 9.8 to 19.6 meter per second. And after again one more second, the velocity will be still it is increased. It is v equal to 29.4 meter per second. See that after every second the speed is being increasing, right? And you can come to know that what is the change in velocity from here in the first second? Yes, find out the change in velocity. It is 9.8 meter per second. Then in the next second, what is the change in velocity? It is the final and this is initial. Final minus initial. Again, it will be 9.8 meter per second. In the third second, change in velocity. Final minus initial. 29.4 minus 19.6. It is 9.8 meter per second. Like this. Observe the change in velocity. Change in velocity in each case is same. Got it? When a body is moving, if it changes its velocity by equal amounts in equal intervals of time. Understood? Here there is change in velocity and that change taken place in the unit time. And we call this as uniform acceleration. Clear? Uniform acceleration. Let me tell the definition of uniform acceleration. Listen carefully. When a body moves along a straight line, if it changes its velocity by equal amounts in equal intervals of time, then it is called uniform acceleration. Example, a freely falling body towards the ground. Clear? Assume that a boy is riding a bicycle in the crowded place. Then what will be the speed? Whether the speed will go on increasing or decreasing, it will be anyhow, it will be changing. Got it? But whether that change in velocity will be same or different, it will be different in equal intervals of time. And we call that acceleration as non-uniform acceleration. And the non-uniform acceleration can be defined as when a body moves along a straight line, if it changes its velocity by unequal amounts in equal intervals of time, then it is called non-uniform acceleration. Example, again, a boy riding the bicycle in the crowded place. Okay. Now I am going to write the definition. You have to copy with me. Okay. Dear students, here I have written the definitions of both uniform acceleration and non-uniform acceleration. Now please copy that. Look here. After writing the definition of uniform acceleration, you give this example and copy this one for understanding. And after writing that, then you come to non-uniform acceleration. Write the definition, take an example and copy this one. Okay? And now again you have to pause the video and start writing from there to here. Just copy. Dear students, now we will focus on the numerical problems on acceleration. These are very important in the examination point of view. Observe here. The first one. Go through this. A car changes its velocity from 18 km per hour to 36 km per hour in 10 seconds. Then calculate its acceleration. Directly they have given. Now, after understanding the statement, a very simple statement, I hope that you all have understood very well. It has changed its velocity from 18 km per hour to 36 km per hour. To change that velocity, how much time it has taken? 10 seconds. Then, what do you call 18 km per hour? You may say that it is velocity, right? 36 km per hour. that is also velocity. But you can come to know that it is changing its velocity from 18 to 36 km per hour. Then 18 is the initial speed and 36 is the final speed. Therefore, we can write u is equal to 18 km per hour initial velocity. Okay. But observe here, to change that velocity it has taken 10 seconds. Whether all the units are in standard? No. Okay, it is kilometer per hour, this is second. Hence, let me go for converting 18 km per hour into meter per second. 18 into 1 km per hour is 5 by 18 meter per second. 18 get cancelled, it will be 5 meter per second. Next, final velocity, that is 36 km per hour. It is 36 into, again 5 by 18 meter per second. 1s are 2s are 2 5s are 10 meter per second. Then what about time? Time is 10 seconds. What you are going to find out? It is acceleration. A equal to question mark. This is the given information. With this information, we have to calculate acceleration by using the formula. What is the acceleration formula? Yes, A equal to V minus U by T. Then what is final velocity? Final velocity is 10. Initial velocity 5. So here I'll write 10 minus 5. Then time taken is 10 seconds divided by 10. 10 minus 5, 5. 5 by 10. It is equal to 1 by 2. 1 by 2 is nothing but 0.5. Here only we could have written directly. 0.5 meter per second square. Hence you can write the conclusion as, therefore the acceleration of the car is 0.5 meter per second square. Here I will write, therefore the acceleration of the car is 0.5 meter per second square. Got it? Please don't copy. Afterwards I'll give you time for writing that. Let's move on to second one. Look here. A bus was moving in a straight line with a speed of 54 km per hour. It was moving with this much speed. On applying the brakes, obviously when the brakes are applied, what happens to the speed? Obviously the speed decreases. It will go on changing, decreasing. Then it stopped. After application of the brake, it has stopped. But to come to the rest, how much time it has taken? It is 8 seconds. So after 8 seconds, it has come to rest. When it comes to rest, what will be the velocity? It will be 0. Then calculate the acceleration. Clear? Now let's go for writing data. What does 54 km per hour indicate? Yes, you are right. It is initial velocity because this is the speed with which bus was moving. 54 km per hour. Observe the unit of another term. Time is given in seconds. So it is in kilometer per hour. Hence it should be converted into seconds. U equal to 54 into 5 by 18 meter per second. 1s are 3s are. Now 5 3s are 15 meter per second. What about the final velocity? That is, on the application of the brakes, it has come to rest. When it comes to rest, the velocity will be 0. 0 meter per second. And to come to rest, it has taken 8 seconds. Time is 8 seconds. You are going to find out acceleration. Calculation. Acceleration formula is A equal to V minus U by T, where V is 0 minus U is 15 and time is 8. It is minus 0 minus 15, minus 15 by 8. You can divide that. 8 1s are 8, 7 will remain 70. 8 8s are 64, 6 will remain 60. Then 8 sevens are 56 minus 1.8 meter per second square. Got it? So this is, now whatever the acceleration we have got, it is negative. What do you call the negative acceleration? It is called deceleration. Clear? Then conclusion. Therefore, the acceleration of the bus is how much? 1.87 meter per second square. Negative sign indicates it is decreasing. Followed? So please, now you have to pause the video and should copy it from here to here. Copy this. Okay. Now let's move on to third one. Before that, for second one we had not written the conclusion. You can copy this one. The acceleration of the bus is minus 1.87 meter per second square. Okay. Now observe that. Third one, it is related to train. Please don't go for copying. You have to listen my words carefully. A train starting from a railway station. Before the start, what was the state of the train? It was at rest, right? That means it has started from the rest position and moving with a uniform acceleration and attains a speed of 40 km per hour. Every time it will go on changing its speed. Got it? But that change in speed will be same because it is moving with uniform acceleration. Attains a speed of 40 km per hour in 10 minutes. Find its acceleration. This is also very simple. Let's go for writing data first. A train starting from a railway station. Before starting, what was the speed? It is u equal to 0 km per hour or meter per second. Next, it attains the speed 40 km per hour. That is the final velocity, 40 km per hour in 10 minutes. Whether the units are in standard? No. Hence, we have to convert them into standard one. Here second is there. Here also it should come in meter per second. 40 into 5 by 18 meter per second. It is now 2 9s are 2 20s are 25s are 500 by 25s are 100 by 9 meter per second. Now time is given. It is equal to 10 minutes. Then time is not in SI unit. What is the SI unit of time? It is seconds. So T is equal to how much? 10 into 1 minute equal to how many seconds? 60 seconds. It is equal to 600 seconds. You are going to find out its acceleration. Let me go for writing the formula. What is the acceleration formula? A equal to V minus U by T. Substitute. What is V? V is 100 by 9. Then minus. What is the initial velocity? It is 0. Now divided by time is 600. Now 100 by 9 minus 0 is 100 by 9 only. In the denominator 600 is there. Take its reciprocal. 600 by 1 is 1 by 600. 0, 0, 0, 0 get cancelled. It is equal to 1 by 9, 6 are 54 meter per second square. Or you can also write 1 by 54 ms raised to the power minus 2. Clear? So this is the acceleration of a train. This is A. I'll write the conclusion. Therefore, the acceleration of the train is 1 by 54 meter per second square. Now let's move on to another one. Don't copy, afterwards I'll give you time. Observe this. A bus decreases its speed from 80 km per hour to 60 km per hour. To change the speed, it has taken 5 seconds. With this information, you are going to find out the acceleration of the bus. Observe the speed. It is decreasing its speed from 80 km per hour to it is 60 km per hour. Then what type of acceleration it is? Positive or negative? It is the negative acceleration. So your final answer should be expressed in negative sign, right? Okay, let us check it out with the calculation. Data. A bus decreases its speed from 80 km per hour. What is its starting speed? 80 km per hour. Then what do you call that starting speed? It is initial velocity. You can call it as u. Observe the unit. Here 5 seconds. Here kilometer per hour is there. Hence you can go for converting this into meter per second. 80 into what is 1 kilometer per hour? It is 5 by 18 meter per second. Just go for cancelling. 2 9s are 2, 4s are 0s. Then 45s are 200 by 9 meter per second. Clear? Okay, next. What about the final velocity? It is 60 km per hour. So this is also not in SI unit. Convert this into meter per second. 60 into again 5 by 18 meter per second. Cancel by 2. 2 9s are 2. 30s are 35s are 150 by 9 meter per second. Again, I think let it be. Calculation will be easier because still it can be cancelled, but in the formula we get v minus u. There it will be easier. Next, time is given. How much? It is 5 seconds. You are going to find out acceleration. Calculation. It is acceleration formula a equal to v minus u by t. Substitute. What is v? Final velocity is 150 by 9 minus initial velocity is 200 by 9. That's why I told. See that when the denominator terms are same, it will be easier to solve. Otherwise, if you had cancelled, you would have taken the LCM and you will go for simplifying. So this is time saving. Time is 5 seconds. It is equal to, what is the LCM? 9. Then take, it is 150 minus 200. You can keep that as it is. Divided by 5. 150 minus 200 is, it is minus 50. Divided by 9. In the denominator, 5 is there. You can go for taking the reciprocal. What is the reciprocal of 5? It is 1 by 5. Now you can cancel. 1s are 10s are. So minus 10 by 9 meter per second square. See that here we have got negative acceleration. Why? Because the bus was decreasing its speed. See that 80 km per hour to 60 km per hour. Hence it attains negative acceleration. So conclusion we can write. Therefore the acceleration of the bus is minus 10 by 9 meter per second square. Actually 10 by 9 meter per second square, that is the acceleration. Negative sign indicates the bus is coming to a halt or coming to stop. I hope that you have understood this. Now you have to pause the video and please copy from here to there. That is third question as well as fourth one. Dear students, so far we have solved numerical problems on acceleration. Okay, and still many are there and they are available in different reference books like Yashchand, Dinesh, Golden. Many are there. You can go for using them. Now we will move on to the next concept. In the next concept, you are going to represent the motion of a body in the graph. Under the heading, graphical representation of motion of a body. Here it has been given in the text. I am going to take the same heading, graphical representation of motion. Graphical representation of Motion. Dear students, motion of an object can be represented in graph by two ways. They are, one is, see that, with respect to velocity, and another one is with respect to acceleration. When you hear the word velocity or speed, immediately distance and time should come into your mind. If it is acceleration, again you have to recall the velocity and time. Got it? And these two are known as, first one is dt graph. dt graph means it is distance time graph. Okay, graph, dt graph, in bracket I'll write distance time graph. Then another one is, it is vt graph. That means velocity time graph. Velocity time graph. Just I'll give you the small information regarding these two. Look here. In dt, then what is dt graph and what is vt graph? When we hear the word graph, obviously we start recalling x-axis and y-axis. The horizontal line is called x-axis and the vertical line is called y-axis. See that this is x-axis and the vertical line is called y-axis. Both will meet at a point, intersect at a point. We call that as origin, represented with O. In case of dt graph, we go for taking time along x-axis, distance along y-axis. I think you may be thinking that why should we take in that order only? See that among these two, which is constant, which is independent? See that time is independent physical quantity, so it will keep on running, whereas distance, see distance, it will be varying. Suppose I start walking, then I may stop. When I stop, the distance will also be stopped. But what about the time? Time will be running. Hence, time is to be considered as independent quantity, and this independent quantity should always be taken along x-axis, and d, it is the variable quantity, hence it is to be taken along y-axis. So this graph is known as dt graph. Let me tell you the definition. The graphical representation of motion in which time is taken along x-axis and distance is taken along y-axis, then it is called dt graph or distance time graph. Clear? And another one, or if you want to define that in a simple way, you can take like this: a graph in which time is taken along x-axis and distance is taken along y-axis is called dt graph. In the same way, vt graph, here see that here x-axis and this is y-axis. In case of vt graph, could you tell where the time should be taken? Again, along x-axis. What is the reason? Because it is independent quantity. Then which is the dependent quantity? It is speed. Hence it should be taken along y-axis. And the graph so obtained is called vt graph. The graphical representation of motion in which time is taken along x-axis and velocity is taken along y-axis is called vt graph. So we have got very good information regarding dt graph and vt graph. Those will be studied in tomorrow's class. Okay. Dear students, before concluding the class, again I want to remind you one thing, that today we have learned an important concept, one important physical quantity, that is acceleration. Along with that, deceleration. Two more words: uniform acceleration and non-uniform acceleration. Even we have solved numerical problems on this acceleration. Please do practice all these today itself and just go through these two. Again, recall that dt graph and vt graph. And before coming to the next class, please go through the textbook if you have NCERT textbook, and you have to read the textbook from page number 104 to 105. It will be easier for understanding the concept what I am going to explain. Okay? Don't waste your time. Please make use of it for practicing today's problem. So with this, let us stop. Thank you.